Hello everyone, welcome to my channel Stream CFD. In this tutorial we will see how to simulate piston effect in a underground metro tunnel. We will be using ANSYS CFX Immerse Solid method for the simulation. First of all, let's get some introduction to Immerse Solid method. As per ANSYS help, it is the capability of ANSYS CFX that enables us to model steady state or transient simulations involving rigid solid objects that can move through fluid domains. Immerse solid method has some limitations. It doesn't support heat transfer, multi-phase, spices, etc. So it cannot model smoke extraction, fire modeling, and environmental control system to analyze human comfort. Also, it cannot model aerodynamics around the train as immersed solid turbulence model cannot accurately predict the pressure field near the immersed boundaries. So if one need to perform simulation for any of the above limitations, then we need to create a new simulation and use the data obtained from this simulation as boundary condition for the further analysis. Now let's begin with the modeling. This is a geometry that we will create. Start ANSYS workbench. First of all, let's save the project. I am naming this project as piston effect. Now pick fluid flow CFX from analysis systems and drop onto project schematics. Now right click geometry and select new design modeler geometry. This will open design modeler. I need to do this because space claim is my default application for geometry. Let me rearrange the toolbars to have more graphic space. Make sure units are set to meter as our dimensions will be in meters. Select ZX plane and click sketching. From toolbars, click look at face. Now draw a rectangle. One side of this rectangle is on x-axis. It will be indicated by C near mouse cursor. Now select semi-automatic from dimensions and place the dimensions. L1 is 20 meters, L2 is 8 meters and V3 is 10 meters. 20 is the length and 8 is the width, and this is symmetric to Z axis. V3 is 10 meters, half of L1. Switch back to modeling. This sketch will be used for station, so I am renaming to station for proper identification. Once again select ZX plane and create two more sketches named tunnel and train. Select tunnel and click on sketching and create a rectangle. Select first point anywhere on top edge of previous rectangle. When selected point is on previous rectangle, it will be indicated by letter C near cursor. Draw rectangle as shown in video. Now go to dimensions and select semi-automatic and place dimensions. Provide dimensions as 5.5 meter length, 4 meter width and 4 meters from the side of previous rectangle. Now select modify and fillet two corners as shown. Now switch back to modeling. select train and switch to sketching. Click modify and then scroll down to select offset. Select all sides of rectangle from tunnel sketch including fillet corners. Once all sides are selected, right click and select End Selection and place offset by clicking inside the rectangle. Now go to dimension and then vertical. First select outer rectangle and then inner rectangle. Place the dimension and provide the dimension as 0.5 meters. Now sketching is complete. Switch back to modeling. Select train sketch. Click extrude from toolbars. Select operation as add frozen because we don't want train to merge with other objects. Depth as 15 meters, its length of compartment, and click generate. Our train has 5 compartments. We need to create 4 more. We will do this using patterns. Select create from menu, pattern, select compartment and click apply. Click direction and select ZX plane normal. Click apply. Gap between compartments is 1 meter. So FD1 is 16 meter, 15 compartment plus 1 gap. Click generate. Select all 5 solid compartments. Right click to form a new part and rename it to train. Now to provide some aesthetics, blend the edges of train compartments. All intermediate edges as 1 meter fixed blend. Press generate. Once again, select fixed blend from toolbars and select first and last edge of train. Enter 3.5 meter as radius and press generate. Now this train we created, initially it should be outside the tunnel. For this we need to translate the train. Select part train, click create from menu and select body transformation, translate. In bodies click apply. Click direction selection and select ZX plane. Reverse the direction and enter FD distance as 101 meter. Click generate. Now we need to create tunnel. For this select the tunnel sketch from ZX plane and click extrude from toolbar. Click apply to geometry. Select operation to add frozen and direction to both symmetric. Depth as 100 meter. Press generate to generate the extrusion. Similarly select station and click extrude from toolbar. Operation as add frozen. Direction to both symmetric and depth as 45 meters. Press generate to generate the extrusion. Now we need to create station, entry, exit, staircase or elevators. For that we will first create a plane. Select XY plane and click new plane from toolbar. Now select transform 1 as offset y and offset distance as minus 25 meters. After that, select transform 2 as rotate around x and value to 45 degrees. Transform 3 as offset global z and offset value to 4 meters. Finally, press generate to generate the plane. Now select newly created plane 4, click look at face from toolbar and click sketching. Create a rectangle with one point on x-axis. It will be indicated by letter C to display the constraint. Click dimensions and select semi-automatic. Place the dimensions and dimension H3 as 3 meter, L1 as 4 meter and L2 as 6 meters. Extrude sketch 4 by clicking extrude button on toolbar and set depth to 25 meters and press generate. Now create a revolve. Select the face and axis as shown. Angle to 45 degrees. Reverse the direction and press generate. Now we need to create one more tunnel, entrance and train on the right side. To do that, we once again use pattern. Select pattern from create menu. Change pattern type to circular. In geometry, select all bodies except station. Axis selection as XY plane and copies to 1 and press generate to generate the pattern. Now we need to merge the station, tunnel and station entrance exit created so far. For this, select all solids and select unfreeze from tools menu and press generate. This will merge station, tunnel and entrance exit to a single part. Now there are only 3 parts named train 1, train 2 and station. I am renaming them so as to have proper identification. Our model creation is complete. Save the project and close the design modeler. In the project schematics, you can see that geometry is complete. Double click on mesh to start meshing. In project outline, select mesh and in details under sizing, Enter max face size as 0.6 meter, max stat size as 0.8 meter and growth rate as 1.15. Press update to update the mesh. Once mesh is generated, zoom to see the mesh. We need to refine the mesh near tunnel walls to have more divisions. For that we will use mesh inflation. In project outline, select mesh and right click, select insert inflation. In geometry, select station body and boundary as tunnel wall except tunnel faces. Once all faces are selected, press update to update the mesh. Now on the tunnel faces, we can see that our mesh have inflation layers along the tunnel walls. Now I will create named selection for tunnel faces and station doors. I am creating all tunnel faces as single name selection, but you can also name the selection individually or as required. Now our mesh is generated. Close the meshing and save the project. In the project schematic, we can see that mesh is complete. Now we proceed to CFX setup. Double click on setup to start CFX Pre. Delete the default domain as we do not want to use default domain. First of all, we will define the expression for motion of the train. Motion of the train is such that initial velocity is 10 meter per second, start stop acceleration is 120 by 360 meter per second square, train arrives at 22 seconds and train departs at 40 seconds. To define, double click on expression in the outline window, right click on expression and insert expression. Enter name as initial velocity and in definition enter 10 meter per second. Click apply. Similarly, define expression zero velocity as 0 meters per second. T arrive as 22 seconds. T depart as 40 seconds. Peak ACC as 120 by 360 meters per second square. Zero ACC as 0 meters per second square. Actual train acceleration will be variable. Acceleration will be negative when train is stopping, 0 when train is stopped and positive when train is starting. We define that variable acceleration by expression ACC. Enter the expression as shown. Instead of typing, you can also use predefined expression by right click expression and select the desired expression. In the same way, actual train velocity is also variable. For that, insert expression velocity and enter the definition as shown. Now, when experimenting with different train speeds, I noticed that at time t arrive, train is having some velocity which is not what we want. To make sure train is actually stopped between t arrive and t depart, insert one more expression final train velocity and enter the definition as shown. Now we have all required expressions. Switch to outline. Double click on analysis type and select analysis type as transient. We will simulate for 80 seconds with 1 second time step. So enter total time as 80 seconds and time step as 1 second. Click OK. Now right click flow analysis 1 and select insert domain. Enter the name as station. Click OK. Click multi-select button next to location and select the station domain by confirming in 3D viewer window. Click OK to complete defining domain. Right click newly created station domain, insert boundary, enter name as tunnel opening. In boundary type select opening. Click multi-select list next to location and select tunnel opening 1 and tunnel opening 2. Switch boundary details tab and enter relative pressure as 0 pascals. Click OK. Similarly, create one more boundary named station door at location station doors with type as opening and relative pressure as 0 pascal. Now click on flow analysis 1, select insert domain, enter name as train 1, click OK. Click multi-select list next to location, select 5 train compartments by confirming in the graphics window, select domain type as image solid. Domain motion option as speed and direction. Click enter formula button next to linear velocity and right click in the text area, select expression, final train velocity. X component as 0, Y component as -1 and Z component as 0. Click OK. Similarly, create second train. Right click on Flow Analysis 1, select Insert Domain, enter name as Train 2, click OK. Click Multi-Select List next to location. Select 5 train compartments by confirming in graphics window. Domain type as Image Solid, domain motion as speed and direction, linear velocity as final train velocity, X component as 0, Y as 1 and Z as 0. Click OK. Now our domain definition is complete. Click on Solver Control in outline. We need not to change anything. Click OK. Now we need to tell CFX to save intermediate time steps. To do that, double click to open output controls. Switch to transient result. Click new button. OK with default name. In output frequency option, select every time step. OK. Now transient result will be saved at every time step. Now this is a transient simulation. We also need to define initial conditions. For that, click initial conditions on toolbar. Enter velocity components and relative pressure as 0. Click OK. Click Save button and close CFX Free. Now to start solving, double click on solution in project schematic to open CFX Solve Manager. I am selecting IBM MPI local parallel and number of partitions as 8. You should select partition as per processor you have in your workstation. Click Start Run to start solving. It will take few hours to solve depending on configuration of your workstation. When solution is complete, close the CFX Solve Manager and save the project. Now the last step is to post-process the simulation results. Now after the solution completes, double click on results in project schematic to open CFD post. Right click in 3D viewer and select predefined camera, isometric view Z up. Click time step selector from toolbar, double click to select step 0 and click close. This will bring the solution to initial conditions. Now click fit view from toolbar. Now click location from toolbar and select surface group. Enter name as trains and click OK. In the domain, select all image solid. In location, select train 1 default and train 2 default using multi-select and click apply. Create one more surface group using locations from toolbar. Enter name as station and select station default in location. Switch to render and enter 0.8 transparency and press apply. I am turning off wireframe, you may keep it on. Now from locations on toolbar, create a plane, accept the default name, enter Z location as 1.5 meter and press apply. Turn off the plane we created and create a contour from toolbar. Enter well in name, press OK. Select location as plane 1, variable as velocity, and range as user specified from 0 meter per second to 10 meter per second, and number of contours as 21. Press apply. Edit default legend from outline, switch to appearance and set precision to 2, fixed, click apply. Now to create animation of velocity, click animations from toolbar, select time frame animation checkbox, check save movie and select desired location. I am changing video format to MP4. After that, click on play button to start saving animations. It will take few minutes to save the movie. While this animation is being saved, you can see the contours and moving trains in the 3D viewer window, and piston effect is clearly visible. Close animations toolbox and similarly create one more contour of pressure on plane 1. Create the movie using animations. Make sure to change the file name to avoid overwriting previous one. Now when movie saving is complete, close the animations toolbox and turn off the contour. Now we will create chart for velocity internal and station entrance throughout the simulation duration at each time step. Insert a point using locations on toolbar. Enter name as tunnel 1. Enter the point as 8, 50 and 1.5 respectively and press apply. Duplicate this point 3 times to create a point in each tunnel and enter the point as shown. Also create 2 points for each station door and point location as shown. Confirm the location of all 6 points we created so far from 3D viewer. Click Insert Chart from toolbar. Enter name as velocity chart. Select type as XY transient or sequence. Enter title as velocity. Switch to data series and select series 1. Enter name as tunnel 1. Select tunnel 1 from location. Create new series and name as tunnel 2. Select location as tunnel 2. Similarly, create the series for tunnel 3, tunnel 4, station door 1 and station door 2 with location as respective points. Switch to Y-axis tab and select variable as velocity. Click apply. This will take few minutes to create the chart. Once the calculation is complete, you can see the velocity profiles at different time steps. Velocity data obtained from this chart can be used to design other services such as tunnel ventilation system and HVAC services for environmental control system. Try experimenting with the results. Let me know in the comments in case you face any difficulty. If you find this video helpful, press like and subscribe to my channel Stream CFD. Thanks for watching and all the best.